Right, I hope that works okay. So what I'd like to talk about today is infrastructure as data. And it's a term that came up for the first time, I think, around August time last year. And Kelsey Hightower, who's very prominent in the Kubernetes world, he coined it as a phrase. I think he wanted to move the discussion on somewhat from infrastructure as code, which had been basically our standard way of working now for quite some time. And what he was really after, he wanted to describe a way of working and deploying infrastructure that is very much as code. So we're still talking about infrastructure as code, but he wanted the nuance to be a little different. And he wanted the nuance to match the way this would happen in a cloud native context. In particular, he wanted to see how would this process appear if we saw it through the lens of the Kubernetes control plane, if we looked at the way that Kubernetes deployments function and how that would influence the whole concept. And in that sense, it's also worth asking why data. So basically, he took the term, it's very clear, it's almost a pun on infrastructure as code. And why did he pick data? And there, I'm sorry to disappoint those who look for data in the data science sense. That's not really what this is about. This is intended as data as in data planes. So we're thinking of, for example, a distributed system where you would have your control plane, which is your main nodes controlling everything, and then you would have your workers. So this is really what happens when we deploy our infrastructure to the workers, when that becomes part of our development workflow. And of course, it's timely because at the end of the year, the second edition of Infrastructure as Code is coming out. So just in time for the holiday season. And so I thought I'd put that here. So the whole topic really is infrastructure as code, but it is rethinking the concept from the perspective of Kubernetes and what it makes possible. Now let's start with the fundamental concept here of infrastructure as code, how it works. We start with a code, be that YAML, be that JSON, and we submit it. Typically, we get a plan back. That would be the Terraform. A project change set has now been made available from CloudFormation. And then we would typically look at that, and then it's basically presented to us for approval. And then if we notice in our Terraform plan that this is about to recreate our production cluster, for example, then we would know, oh, we made a mistake here. So let's go back to the code and fix this. Other than that, if we're happy, we would go through and the deployment would happen. So you've very much got a linear process here that starts from the beginning, has a checkpoint, but then basically it goes through to the infrastructure. Now, what Kelsey Hightower stressed here, and we'll look at his exact words in just a moment, is really what changes when you take the human element out of this. So here we have an approach of continuous reconciliation. So you have the code still at the beginning. This is, as I said, infrastructure as code. So this describes a desired state, but this now goes into a reconciliation loop. And the key to this really is that it is a loop. This is not an A to B process of the kind we looked at just now. And there are several important elements here, because what happens is that each time this reconciliation loop revolves, we're looking at admission. So what do I do with these objects that have been submitted to the cluster? Can I grant access? So this will be what the control plane asks itself. And there's always policy. So we, as the users of the cluster, can express policy in a very clear way, which basically each time this goes around can check. And then this, of course, is dynamic. So we can change the policy over time. Admission rules might change over time. And so all of that will influence the current state over time. So this, I've tried to sort of here basically bring this together in a single slide, is my understanding of infrastructure as data. And now let's take a look at Kelsey Hightower's actual words. Now, interestingly, you see, there isn't an article or book that I'm aware of. So we have a handful of tweets and a dozen or so podcasts to go on. I do recommend the podcasts. If you just search for Kelsey Hightower and podcast, you'll find plenty. And he went on a whistle-stop tour of infra podcasts towards the end of last year, and he kept introducing this concept. And so quite a few of those discussions I thought were really fruitful. And what he said this tweet, I thought summed it up best. So declarative configuration is about treating infrastructure as data, which he says is more portable than code and enables workflows that manipulate desired state based on policy. A few things to emphasize here is the desired state that is being manipulated. So this is not actually talking. This is the key really to the reconciliation loop. It's what goes into it that is formed. And it is formed every time that reconciliation loop comes around again. And of course, the policy, the fact that we set this in terms of policy. And if you recall what we looked at earlier, our Terraform plan or CloudFormation change set is very different in nature. This is an A to B relationship. And although I can run that many times, and of course I have certain guarantees that the item potency will be preserved and so on, the key here is that I don't need a human in this particular picture. So humans specify the policy, humans specify the desired state as it is presented in serialized form as code early on. But after that, we basically have a system that takes care of itself. So I think that is really fundamentally what the concept is about. Now, why should we care about that? Why should that matter? And I'll be the first to admit that this sounds like a rather niche subject. So we're looking at infrastructure as code, which of course is a big subject. We've got big industry tools, and this has very much become the standard way of working for us. But what about the data aspect of it? And I would like to tackle this question by asking a few more questions. For example, why do the major cloud vendors seem to care an awful lot about this? So the idea that we deploy infrastructure via and into our clusters, Kubernetes clusters, has really been occupying the minds at the large cloud vendors, no end. And I'd like to talk about that and present some ideas about why I think that is the case. It's also, you see, the large open source vendors, and some of them not so large, who've actually really doubled down on this. So MongoDB Inc. is a good example of a company that really has bet the house on this particular way of deploying infrastructure working for them. And so major cloud vendors, why do they care? We have the MongoDBs and the other open source companies. And I really also want to focus on the developers. So what's in it for the developers? And then I'd like to close out at the end just with a consideration of where are we on the timeline towards this possible future? And if and when this will actually be something that we would want to recommend to clients. Now, let me start with the cloud vendors. And I gathered this data a little while back, a few months now, and I'm finding this a really startling graph. So what this shows us is the number of regions that are springing up over time. And I should say, and I did note at the bottom here, that these regions vary very significantly in size. So although the pink area is by no means the largest here, that is simply because those regions, the data centers in the Amazon regions, tend to be larger. So the absolute values aren't really what this is about. Two things in particular really strike me about this graph. One is towards the right-hand side, that the market seems to soak up supply. So you've got a bunch of huge companies essentially building out data centers, cloud data centers, as fast as basically the planning process will allow. On the right-hand side. So we've got this incredible explosion of demand and supply. And on the left-hand side is the strangest thing of all. We have, and 2006 wasn't even the beginning. The simple queue service came before. But 2006, that's basically the first record I could find of an actual region. This was Compute One, it was called. And then we have 2006 passes, 2007, 2008, 2009, the first competitor on the scene is actually Alibaba Cloud. It's not Google, it's not Microsoft. Following year, we get the first time that we actually have Microsoft in the picture, and then Google appears on the scene, so the dark blue line here. And I just wanted to dwell on that for a moment. This strikes me as truly extraordinary. If we think for a moment that Google had approached the iPhone in the same way, it appeared in 2007, and they say, let's wait, it'll never catch on, and we can always catch up later if we need to. No, that's not what they did. In fact, there was a very serious threat of litigation and Steve Jobs, in fact, threatened thermonuclear war, if I remember correctly, over attempts to copy the iPhone, and they did it anyway. So Android, just imagine, where would Android be today if Google had just sat on the fence for 3 or 4 years? I think the simple fact is that there would be no Android today. And I think it is truly remarkable that Amazon managed, with its AWS offering, to be completely alone in being allowed to build this out, to win the early customers, and basically set up this huge infrastructure that has become such a key part of their company setup. Now, this is the starting point, really. If we look at sort of why does the cloud, why do the large cloud vendors look at this particular topic that we've got? The infrastructure is data. Now, what does that buy you if people let you get away with a head start like that? This buys you a wall of products like that, an incredibly 150 plus strong range of products, most of them very high level of maturity. And now the competition's on, right? Now everybody else has realized, oh, there's actually a ton of money to be made here. This might just be the future of computing. So this dawns on everybody now by 2010, 2011, I'm sure. And the really interesting thing is, no matter how fast you try to follow, you can't very easily catch up with this. And I realized many companies are trying, and the rival offerings are, of course, growing apace, but so is AWS. So I just wanted to have that really as our starting picture of sort of what happens when you let somebody like a company like AWS basically run with it for a number of years unopposed. And at that point really is where Kubernetes enters the picture. So just a few years ago, version 1.0, this was actually a happy family, and all happy families are alike, as they say. So this was really sort of quite wild. Lots of companies, small companies, large companies, thought they'd have a go at making container orchestration work. And the interesting thing was that a few years on, realistically, this is where we are. So this particular conflict has really been resolved. There has been no offering that has actually been in the container orchestration space, at least, that has been able to stay current, stay relevant in the way that Kubernetes has. And it's again worth asking, how did this happen? Because that really plays back into the importance of what Kelsey Hightower means when he's talking about infrastructure as data. Essentially what happened, everyone ended up taking a stake in Kubernetes, but crucially, nobody was given a controlling stake. Now, this was Google's to give away, and they decided to give it away to the Cloud Native Computing Foundation. Interestingly, more recently, with other projects, Istio comes to mind, they actually didn't decide to do that again. So perhaps from hindsight, they thought actually the balance of the trade-offs weren't quite right with this. But what we certainly ended up with is the extremely strong Cloud Native Computing Foundation, and we have all these huge players basically rooting for Kubernetes, trying to make a success of Kubernetes. And that is really what I want to now sort of zoom in on a little, sort of what creates a project that has that kind of effect? How do you get rivals like Red Hat, IBM, Microsoft, VMware, Google? How do you get them all working together on a single project? That strikes me as a fairly extraordinary thing to have happened. And one thing, if you look at an upstream, so an open source project whose upstream is the actual version and lots of very different companies contributing to it, one good sign is if you have breakaway projects. In this case, in the early days, there was OpenShift, which took Kubernetes from around version 1.0, and they innovated on top of it. They had their own offering, their own product, which was OpenShift 3 and on. And for example, you would have Kubernetes. They had attribute-based access control, a very simple form of access control. Now, OpenShift and Red Hat innovated on top of that. They had the idea of roles and cluster roles. And only later, when they pushed this back upstream, did this actually get standardized as part of the Kubernetes code base. And back came the role-based access control, the RBAC that we know today, which is universally how access control works in modern Kubernetes clusters. And so the pizza effect analogy really is just thinking of immigrants from Italy landing in New York, opening a restaurant, thinking, oh, what was that dish? Pizza, that might work. And they actually invent a brand new dish. But then it gets re-imported back into Italy, where now you will find many restaurants offering pizza as, of course, a traditional dish, when arguably this is really the New York dish that they're offering. And interestingly, there were many of these examples. So I've just picked out two fairly at random, the networking side of things. For example, Kubernetes launched with a flat network. Every workload could talk to every other workload. And OpenShift, again, with an enterprise focus, with the early enterprise customers, they needed to split that. They wanted a multi-tenant plugin, so they could say, if you're in this namespace, you can talk to others. If in that, you can't, for example. So they had that, and then they followed that up with prototype network policies. And again, as in the previous example, after a while, this got standardized as part of the main Kubernetes upstream. And now these are the network policies you use. And of course, at that point, then, if you're using OpenShift today, you'll also be using those standardized network policies. You would typically no longer use the multi-tenant plugin that Red Hat created in the early days. So if I try to sum up what makes a project like that, and I think this is absolutely crucial to the evolution of how Kubernetes got to where it is. You have a starting point, and it has to be open source. It has to be a suitably permissive license. But what's really important is that that alone isn't enough. You really need that neutral IP ownership that was made possible when Google gifted Kubernetes to the Cloud Native Computing Foundation. And I really like this tweet here from Matt Klein of Envoy fame. Kubernetes would not be what it is today without neutral IP ownership. It has spawned an entire ecosystem because it can be used by consuming projects without fear. And I think that's really important to stress. And also why I find it a little sad that Google decided for later projects not to follow this path again, because by all appearances, this was wildly successful. And I don't think anybody would have dreamed when they initially launched Kubernetes that it would become as successful as it has. Obviously, for the company and for business, there are other considerations too. So they may have now judged that it is important to be open source, but perhaps that the IP ownership should not be as managed in the way that it was, which is, of course, their call. Now, the third part, which again, I think is absolutely crucial, is that there is a way to extend this. And this is important. If you think about those companies, the IBMs, the Microsofts, and Alibaba, any of the large players, and indeed VMware are now sort of very, very active in this space, partly through targeted acquisitions. When we look at this, it is really important for there to be a generic mechanism that allows you to extend how this works. And the mechanism that they came up with is actually extremely powerful. So from the early days, there was the concept of controllers. We spoke earlier about, we had the admission, and I said admission. So there's an admission controller that basically applies the policy about what can be admitted. Similarly, the role-based access control is implemented as a controller. And of course, any policy that we add to the central loop, all of that is essentially implemented as a controller. And then when we pair these with a custom resource definition, that means within the Kubernetes universe, I can give it a name. I can call this a vault service, or I can call this a SQL database. And I have that name and I have an object that I can deploy. Then these are known as operators. So controllers and operators play a really important part in this story too. Now, if we want to look at that pattern in clear text, essentially you would have something like a custom resource definition. And this is again the example I had just now, the vault service. Where do I mention that? It's very much a first party one. So the vault service was actually the second operator that the creators of the operator pattern came up with. So that's why I think it's a good example. It has the controller. It has to, I'm sorry, and that was CoreOS was the company. And then you will find in the history of Kubernetes that CoreOS punched way, way above their weight. And indeed, Kelsey Hightower himself used to work for them. So if we have the controller, here again, paired with our custom resource definition, And key to this collaboration is that this has got direct access to cluster state. So the etcd database that underpins the main servers that make up the control plane of your Kubernetes cluster, sort of in that system is in etcd. And we have persistent volumes, you have config maps, you have secrets. So all of these means of achieving state, achieving persistence. And you could easily, by the way, extend that. And from the very early days, it was possible, for example, to create perfectly plain load balancers, elastic load balancers, if you were deploying to AWS. So you would have a service object, and that service object in turn would create a load balancer. Now that would be in elastic load balancer like any other in the AWS world. So it has always been possible to actually transfer across from the container-focused world into the larger cloud around it. Now, what's in it for Amazon's rivals? Perhaps forlorn, but there is a chance just to catch up. So if we think about for a moment, trying to compete with these 150 products and going product by product by product, you'd be busy in 10 years' time. You just don't have the momentum behind you. Now, what really caught the attention of these companies was that if they can make stateful applications using the operator pattern on Kubernetes work well enough, they could actually dispense with that. They wouldn't need those 150 services. What they need is a really rock solid managed Kubernetes offering. And within that, they would then, so the plan goes, be able to deploy everything else. They would be able to deploy their databases in there. They would be able to deploy their queues, your Kafka cluster, all of those things. So that is the dream. And I think it's just important to say, this is why so much emphasis falls on that. Because those companies are huge. Those companies are also hugely profitable. So for them, the cloud is already working, but this for them would clinch it. Because this is the best chance there is currently to try and make up lost ground. So this is really just the idea. Imagine not having to compete with this wall of products. And now the segue is that what you would offer instead is a catalog of managed open source products with first-party support. And that really takes us into the next section. Because what about the open source companies? And for them, this really is make or break. Think for a moment about what happened in the last few years. If you were, for example, a company managing SQL databases for clients, it has become incredibly hard to compete with RDS. If a company is in the AWS world or the equivalent SQL offering for Azure or for GCP, it is really, really hard to compete with that. And so what happened was that the cloud vendors, I think Amazon really pioneered that and did it very effectively. So they introduced managed services based on open source products, and that really put the commercial vendors creating and supporting those products on notice. Because once I've bought, or rather once I'm renting RDS instances from Amazon, that's probably good enough for me. I'm now not going to go and say, well, actually, I want to talk to the people who built this and I want to pay them money too. Or for example, if it was the MySQL option of RDS, would you then go to Oracle and say, oh, can I have your support? Why would you? Because this is already supported by AWS and you already trust this. So this is really where MongoDB came from when they published their server-side public license, which in essence said, this is an open source license, but sadly, we cannot make our product available to you if you are a major cloud vendor. Not in so many words, but basically they had to make it, in their view, impossible for AWS to just come out and have, for example, add MongoDB as a special flavor to one of their database offerings. And I know that argument goes both ways, and I've heard it argued in the other direction too, that all advertisement is good advertisement and that financially these companies may be doing fine. I do think it's important to realize that if this was one's own company, this is quite a scary spot to be in. If I'm MongoDB and Amazon are readying a product that uses my code, but they will be offering the support for it, how do I compete with that? I do think we have to accept that that is quite a scary place to be in. And I can see why they felt they had to act. And I know there's a lot of controversy around whether essentially breaking up the open source licenses that have served us well over many years is the way to do it. But I think it's important to just recognize the real tension and the real strain that these companies were under. Now, to the dream, right? The promise of Kubernetes really is to simplify this fundamentally. So where just now we had the secrets manager, you could have the vault operator. Where just now we had RDS, you could put in one of the available PostgreSQL operators. Where we had code pipeline, you could say, hey, Jenkins X might be a good fit. And we'll come to talk about sort of how direct those equivalencies actually are. There's a lot to be said there. And we had SQS in the previous slide, so why not say a Kafka operator here? And I picked Kafka rather than RabbitMQ, which is also available as an operator, because Kafka actually is supported first party and claims production readiness. So this, if I look at this as like the dream scenario for these open source vendors, for them, the operator pattern really holds out the promise of a sustainable business model. And if they're already sustainable, then perhaps more sustainable, but basically they want to lift that particular predicament they're under, that they feel they're under threat at any moment to basically be knocked out of existence by a major cloud just publishing their software and offering its own support for it. Now, I would like to look at that particular relationship, that move from infrastructure as code to infrastructure as data, with a couple of different lenses now. So if we look at this, we could say previously, in the on the upper side, where we have the secrets manager, the RDS, all these proprietary tools. So you would look at sort of, this is proprietary, it's sticky. If I want to change cloud, this is going to be hard work because I'm going to have used all of these RDS or other. RDS is not actually the best example here for stickiness because that does still give you Postgres, it gives you MySQL and so on. But let's imagine for a moment you chose DynamoDB. That is truly a sticky database because it's insanely powerful, but it is also just not transferable. You can't have a DynamoDB in that same way using the same APIs on another cloud today. And next to those two, I think we have to be fair. We have to say these are extremely mature. These are robust, solid, mature, fully integrated. And for many of our clients, of course, these are already in place. So this makes it hard to compete with them. Now in the middle here, we have EKS. So we have the Elastic Kubernetes service, and which itself, of course, again, is a managed service. It's an open source product, but it's a managed service. So AWS look after it, and certain parts of how they manage it are proprietary. But generally, what happens inside that cluster is open source. It's less sticky. I can move from cloud to cloud. However, it's also less mature. Nobody today claims that the Kafka operator running inside your Kubernetes cluster has got the maturity of SQS, which also has the special distinction of being the earliest Amazon product, AWS product. Right, and so if we just look at that lens again for down here, you just see you're expanding the part that is open source, you're expanding the part that is less sticky, but you're also taking the hit because you're also having more software that is less mature here. But you're shrinking the bit that is proprietary, sticky, however also mature. Now let's switch the lens somewhat. If we look at how we deploy this, the reconciliation loop we've been talking about, if you're deploying EKS and all the services around it are in fact your proprietary fully integrated AWS services, the reconciliation loop is only going to happen in the little part that happens inside your cluster. Everything around it would still be CloudFormation, would still be Terraform. You would still be in the world of infrastructure as code very firmly, which basically means that you're here, you're writing your plans and you're putting that together. And essentially what you're doing here is you're expanding, this time you're expanding the reconciliation loop aspect of this. So the part where you have that continuous loop going that I talked about earlier. And your plan becomes a tiny part because your plan basically becomes, let there be a cluster. And there would probably be a destroy option next to it. So let there be no cluster anymore. But basically, apart from that, this is very, very minor. just very little code. Now, just one more of these. If we look at this in terms of abstraction now, we can look at sort of the Terraform that manages all of it. And at the top, I would say that what we're looking at here, this is at least 1,000 lines. I would say 1,000 lines plus, a lot of Terraform. And not least because underneath that, the Terraform is actually describing a lot of IAM policies. It's describing security groups and network access control lists, and of course all the storage. So there'll be S3 and EBS, perhaps NFS, so in the form of EFS. And only within that, right? So only the little bit that happens inside the managed cluster would we now be talking about RBAC instead of IAM, would be talking about CNI, so the container network interface, instead of security groups and NACLs, and the storage interface instead of S3, EBS, EFS. And again, the same relationship holds here that we looked at just now, where basically we're expanding massively the part that will be under control of RBAC and CNI and CSI. So the networking, the storage, and authorization pieces basically become things that are managed by Kubernetes and become part of that continuous control loop. And I would expect there to be far less Terraform here. In this case, you do, of course, gain code that you write within it. But just on that side, if we just try to balance out, so how much infrastructure as code is there and how much infrastructure as data, if we want to just split them sharply like that. And with that, we really come to the developers. And I think the developers are a really important group here. Because you see, businesses, for the most part, are no rush to adopt multi-cloud. So I read quite a lot about Kubernetes correlates strongly with multi-cloud adoption, which is fine. But the fact is that multi-cloud for most companies solves a problem they don't have. So they can sit, they don't have to act. And that's fine. And we look here, so these are the figures, the latest available from Sumo Logic, the continuous intelligence report, which I love actually, because this is real data. Basically from Sumo Logic's customers, sort of we know these are actually reliable figures, which I think are really precious, although of course there's always going to be, not everybody's a Sumo customer, so there's always a certain bias here. But it's important to know this 64% here, these are the people who are on AWS and just AWS, and they're in no rush to move. And we have got multi-cloud 13%, to be honest, that actually struck me as quite high, and they do point out in this report that it's growing. But I wonder, for example, how much that might be somebody trying out something in a hybrid way. Okay, there's this particular feature I like about Google Cloud, so let's have a little project in that. And already you're part of the 13%. And other clouds, it's actually striking how few there are, but there seems to be a strong correlation also of AWS and of course Sumo Logic. So, and then finally the other end on-prem, just 15%. So I really found that striking as sort of, this is the position of the businesses, but the developers don't have that luxury. As a developer, you are living in the multi-cloud world right now, today. And what that means for you as a developer is that you're looking at the cloud training, and that really divides quite rigidly along vendor lines. So you might be doing the AWS Certified Solutions Architect. And then the moment you finish that, people will call you and say, oh, hey, what about the developer one? I heard that's good. Or the SysOps one. And those basically who think you've got a lot of time will say, well, come on, get on, sort of do the professional now. And of course, your next project might be on Azure. So what do you do? So do you start again? So do you do the solutions architect? Do you then branch out? And next project might be on Google Cloud. And I wanted to pause for a quick moment on this, because the Kubernetes promise is really tightly linked to this idea that not just businesses get to work across clouds, but you have a greater set of shared transferable skills for the developers too. So I think it's important to look at this and say, and by the way, this being a very, very active part of the industry, these are great courses, right? The videos they're producing are fantastic, and the test questions are great, and the books are well produced, shiny, the exams, everything. Sort of this industry is a well-oiled machine. And I encourage everybody to take these courses. But I think it's also important as developers to realize that there's a certain price. And one thing, if I spend 3 months, for example, on one of these certifications, that means I have less time to spend on learning languages. And I think that's quite striking. You could say, oh, these are all languages, just infrastructure. If I look at Rust and Go, for example, Go, the entire cloud native stack, more or less, seems to be written in Go. So that as an infrastructure person, I think, oh, that's a language I want to really delve deep into. And if I look at Rust, I see, oh, what have Amazon been up to? Sort of there's Bottle Rocket with intriguing parts of Rust in their new Linux distro. And of course, there's the backbone for their serverless offering, so Lambda, and we have Firecracker. And that again sort of had sort of really interesting parts of Rust in it. So those are languages. And the two things to note about them is that they haven't been around long. So the only two that really sort of strike out here in terms of age are Python and JavaScript. And the rest, for the most part, less than 10 years old, which is really striking. So this is something that developers love to do. They love to learn languages. And I think as we're asking developers to do more and more, now it's Azure, next year it's GCP, after that, do the professional on AWS, this is going to be in conflict with that at some point. This is time that people spend to learn languages. And when we learn languages, we don't just learn the language, we actually want to build stuff. So this is project time. This is all of these things. I think it's important to just be aware of that opportunity cost. And that's another thing. We're actually losing with that rigid vertical silo building. When you go into one of those systems and basically you feel good about having done your first cert, and then basically the next certificate comes along and you say, oh yeah, I want to do that too. And you feel so this is almost like a family that you're in. But what increasingly becomes harder to see is actually, what does this look like if I take a step back? And just a little while ago, I wanted to know, how do those object storage offers actually compare? And I had to admit at that point, I really did not know. I worked in one cloud, then I worked in another cloud. I just couldn't say. So I thought, actually, I'm just going to sit down and just write down that table in a simple JSON and just basically have the prices as they were that day. I think, yes, it was the 21st of September. I basically checked my figures to put this together. And there's some things that are really fascinating, because this is when you actually start looking at business models. And you actually see how both Google and Microsoft are bookending the price ranges that Amazon have. So Amazon with the round shapes, of course, so really bookended to the left on the lower edge of that price boundary, sort of for both Google and for Azure. And then absolutely fascinating, the product, the solid state product that Microsoft have. And I hadn't noticed that. To be honest, I had to switch the scale to square root just to get it on here at all. It's so much more expensive. So I'd love to know, what are they on about? And interesting outliers like the infrequent access product from AWS, where they say, okay, one availability zone is enough for you. Durability guarantee is the same. Availability, of course, drops significantly, 99.5. And then you see, actually, it's not that much cheaper. And there are actually sort of much higher availability sort of for some of these other products at similar price points. And another thing, as we're focusing more and more on what these individual clouds have in their marvelous proprietary offerings, and they are marvelous, right? These are marvels of engineering, and I don't want to take anything away from that. But what we're actually lacking is we're not noticing a startup like Wasabi coming up. They've got their delightfully named Wasabi Hot Cloud Storage. And then this takes us right here. So this is the cross shape, which is quite extraordinary to me. How they can actually undercut meaningfully all of these vendors who have insane economies of scale. So they're going to the left of that. So the only triangle to the left of it, this is cold storage. This is not really a fair comparison. You've got totally different fee structure when you retrieve that data. So that, looking at that really sort of, it blows my mind. How Wasabi do that? And that is the kind of question I want us to be asking of the cloud ecosystem. And again, it's right that we do these certification courses, but I think it's also right that we retain that bit where we're trying to look across what they're offering. And that, again, is where Kubernetes comes into it, because what it offers us, or what it seeks to offer, is building blocks for building platforms in such a way that we get a virtual and portable data center. So that is what we have when we have the Kubernetes managed cluster, when we have the role-based access controls on top. And then we have what essentially makes up your data center. We have the compute, the container runtime, we have the networking, container network interface, and you have the storage. And if you take all that together and you look at the rapid rise of the cloud platforms and you think, so where's this all going? And where's the place of open source going to be in this? I think you'll be hard pushed not to root for Kubernetes if you're somebody who loves open source. Now, having tried to make the case for it, I do think it's an exciting promise. I think that also the premise, I think, is an interesting one. I can see quite a few technical challenges, but really the key for us is also, when do we feel this is ready to recommend? When do we feel this is actually something we can go out and say, actually, this is what you want to do? So go back to the tweet. This is Kelsey Hightower said it, and we think this holds water, and this is going to be an exciting development. This is going to work well for you as a company. And that's a much harder trade-off to call. So really, the benefit for clients are less clear than those for cloud vendors and open source companies. I think that's really important to bear in mind. We saw earlier, for the companies, they're in no rush to embrace multi-cloud. Those benefits that we see, the benefit that, for example, a developer sees when they only have to learn it once, and that skill now is transferable across all the major clouds. That's great. But for the company that's on AWS or on Azure and happy there and has no intention of ever moving to another cloud, at least not in the immediate future, it's a much harder call to make. And in addition to that, this is a Brandon Phillips, I think a really important statement. This comes from the actual original blog post introducing operators. And this is what he said: stateless is easy, stateful is hard. And this is the person who tried to fix the problem. This is the person who actually took this and said, we need to fix state in Kubernetes. This is important, and we need to fix this. And this really plays into all of the concerns that we've been talking about tonight, about the idea of what do you do if you're a big cloud vendor and you've lost years and years and you're trying to catch up? How do you see a future in which you can compete on even terms? It's that important. But at the same time, you have to be realistic, and you have to say, this is really hard and will take time. We'll need time to get this right. And of course, simple question: can a PostgreSQL operator match the availability and durability, the guarantees of an RDS? And the simple answer is no, not today. And it's really interesting because the promise is there, and we can bear in mind that the primitives are the same. So there's no special source EBS volume that RDS uses that isn't available to everybody else using AWS. However, the integration is such and the product maturity is such that it will be a long time before we can get close to that. And there's a really interesting development in recent weeks where essentially Amazon themselves now offer their AWS controllers for Kubernetes. And that might well be the best entry path into infrastructure as data, where you don't deploy your RDS database via Terraform anymore, but instead you make it an operator within your managed EKS cluster. So this is really the somewhat tricky picture I would like to leave you with. As you can probably tell, I'm really excited about this. I think this holds out tons of potential. I'm personally really rooting for it also just from the open source angle. I'm somewhat concerned that there's such a stack of top quality, fully proprietary software being developed that we're all basically funneled into, that we're all working with. And I wonder sort of, where's this going to end? Where's this going to go? At the same time, we have to be realistic. We have to say, okay, the Kafka operators here, we have first-party support from Confluent, from the makers, the main developers behind it. So that's good, but it's not managed service, managed streaming for Kafka. If I buy the MSK product from AWS today, I would expect more resilience. I would expect more robustness from that than I can achieve today with the Kafka operator. Postgres is interesting, generally databases. So we have two good and very well-established Postgres operators. There's a first-party operator from Oracle for MySQL, and now brand new, the CNCF graduate project Vitesse, which blog posts tell us they're wonderful, podcasts say it's wonderful, but again, it's not RDS, right? It's not yet plug and play. It doesn't have that level of maturity yet. And the other thing I came across, I was really interested in Jenkins X, because what Jenkins X essentially does is it takes the components of a continuous delivery system, which which we've been working with all this while now. Sort of, we're looking at different tools, and they're quite exciting. And then when I actually installed them, when I ran it, I was a bit disappointed at first, because I realized this has nothing to do with Hudson. And not that I miss the optics of Hudson, but I did think there might be an interface there. And the fact is that if you want a UI for Jenkins X, you install Octant, which is a great tool from VMware. So it's absolutely fine. Sorry, not VMware. I'm getting that twisted, sorry. But basically, I'm using the Octant JX plugin. And so that's a very different approach. So this is not really a like-for-like comparison. And I think that's really what I would just like to stress in closing. I think this is one to assess. If using something like an AWS controller for Kubernetes, perhaps trial, but I wouldn't adopt it yet. And I say that with a sad heart, because I've been following it now for a little while. I'm really rooting for this. I think it's exciting technology. It has tons of promise, but at the same time, it's not there yet. Thank you.